Hi, I'm Dr. Padilla. Here we talk about all things data visualization, and today we are doing a critique on color. Looking at different visualizations that use color in different ways will help us gain some intuitions about how to use color effectively in our own visualization. So let's jump in. Here we have an animation that is produced by Ed Hawkins and Mark Subero, and what it is showing you is these spiral data that is indicating the temperature across different years. And it's essentially building up this spiral, and the color, which is what I want you to focus on, is part of what is encoding the temperature. So you can see we're starting to get more red, increasingly more red colors as time goes on. Now this is pretty impressive. The cool part is that it animates as well, and it shows you the spiral information, showing you the early years at the bottom, the more recent years at the top, and it very clearly indicates that the global temperatures are increasing over time, both with color and with the width of the spiral itself. Okay, let's compare this overall style to something that might seem very similar from the onset if you don't know anything about data visualization. Okay, here we have an animation produced by the National Institute of Health, and it is part of the Connectome project. What it's showing you is the hippocampus, which is an area in the brain associated with memory, navigation, a few other things, and it's showing you the interconnection between the hippocampus and other regions. Okay, beautiful, right? It is lovely. It also has this dynamic use of color. What do you actually think about the coloring itself? Can we interpret the color? What is the color telling us other than this is a beautiful, high quality, scientific visualization? Let's compare these side by side. The one on the left encodes color with temperature, where the lighter colors like blue are lower temperatures and the red colors are hotter temperatures. And that is a fairly intuitive mapping. The one on the right, it's pretty challenging to figure out what the colors actually map onto. These both look like high quality scientific visualizations that are produced using lots of computational power. But the one on the right is very, very challenging to read in terms of the color. And in fact, they add this legend down here that describes how to use the color. And it's still very challenging to understand even when you read this very long annotation here. And that's usually what we see when people begin using color, that they're very excited and they want to make something beautiful and dynamic and poppy. And that is certainly what happens with the one on the right. And people tout these connectome visualizations as one of the best scientific visualizations out there. I think it is one of the worst uses of color that exists, in part because there's no clear associations that we can glean from these colors. We have to look at the legend. The legend is pretty obscure and it's very hard to interpret individual values, in part because it's continuous across a rainbow scale. And we'll learn in a few videos from now why a rainbow color map is bad. So there's a lot that's going wrong in this visualization, even though people love these connectome visualizations. And that's probably in part because the actual underlying science is fantastic. Finding ways to represent the connections in the brain is really advanced, but the coloring that they've used to create these visualizations seems to be done just to make them flashy and exciting to get people's attention. Where the one on the left encodes color in a meaningful way and is very easy to interpret. And in fact, another version of the same type of data is the one on the right by Ed Hawkins. This is a very famous visualization that has been used to very simply illustrate that overall global temperatures are rising. And it does that with just color. That is the only real information that we're being presented here is color. And it can clearly communicate that these more recent years, there are higher temperatures. Here's what the plot would look like if it was done in a bar chart. And we have a video where we've replicated part of this to some degree. The bar chart can help if you want to read exact values, but the main message is really communicated with this one on the left by simply really eloquent selection of color. So much so that it's become sort of a meme. It appears on all types of different products, on billboards. It is really a movement, in part because it was a very clear illustration that the planet is getting warmer and warmer in a way that can emotionally impact people. If we look closely at this, one of the things that hits me when I'm just deeply considering this is that these kind of red areas feel urgent, feel scary. There's kind of a smooth transition of blue and all of a sudden this rise of dark red. And in some cultures, dark red is associated with more negative types of things. So that was a very astute selection of this color palette here. Let's look at a more artistic example. This visualization is produced by Frederica. She's a really amazing visualization visualization artist, if you will. And in particular, I like her use of color in this. The caption reads, "At least 230 people have been killed since the beginning of the protests in Iran, including at least 29 children and teenagers. And each one of these lines is one person. And one of the light colored lines is a person under the age of 18. So she's kind of using this hair metaphor and encoding data with it, but also using the colors to represent information in an emotional way. And I think the thing that's even more powerful than that just direct encoding there is this missing data here. What she's representing is missing people that are potentially in these totals. And I think this is a really beautiful way to indicate missing values with this relationship between color and line marks, which is really fabulous. But you don't have to use color just to encode negative things like the climate warming or deaths. Here's another really excellent version that uses color to encode the sound of a crowd. I'll play it here. As you're watching this, what you are seeing, obviously, is as the crowd gets louder in different areas of the stadium, both the size of the height of the bars goes up and the color changes to be more intense, more bright white, more kind of yellow as opposed to an orange gold. And this is really an expert application of a few encoding channels at a time, but in particular, I like their use of color because those hot white areas seem to me to represent sound that has a really strong resonance, this bright white, really loud crowd sound. So it seems to simulate the feeling of being in a crowd by simply really expert selection of the color used in addition to these other visual encoding channels. The rotation may be a little unnecessary in this case, but it makes it pretty interactive and fun. Okay, let's look at some bad examples. I want you to take a look at both of these visualizations and pause the video now and try to decide why these are using color poorly. What do you think about these? What don't you like? What should they be doing differently? All right, what do you think? There's sort of a lot going wrong in these visualizations, but you really do see people use color like this when they're first starting out. When they're not thinking about it, they just want to color encode their visualization to make it beautiful and exciting. Well, let's start with the one on the left. First major thing is that they're simply using too many colors. It is very hard to distinguish these individual colors. They've done some work to kind of group them all together, but there's just simply too many colors here to add meaningful insights to this visualization. It's adding to the chaos of what you see here. And these visualizations can tend to be very confusing for the average person. So making it even more confusing with all of these colors is very challenging. It'd be really hard to kind of follow any of these lines through here because of the color. It's simply too many colors. Okay, the one on the right, what is going on here is obviously too many colors, same as the one on the left, but it's also using transparency. When you combine transparency with a great number of colors, when you start to see these overlapping sections, it can be really challenging to identify the individual value because when colors overlap, they will combine to make new and different colors. And it can be very challenging in this case and add a lot more visual complexity when you have many colors and some transparency. And we've seen this in a few of the programming tutorials where I'll point out that maybe what we're doing should be changed because we have opacity combined with color. And in some cases, it's hard to distinguish if something is a different color or if it's just two things being overlapped on one another. Of course, I have to point out that it's also a 3D pie chart. We're talking about color today, not how bad 3D pie charts are, but I would be remiss if I didn't point that out. Essentially, 3D pie charts, because they're angled in space, it appears as if these areas are larger than these back here, simply because they're in 3D versus just a flat 2D pie chart. So let's look at these groupings of good and bad uses of color. The ones that I've highlighted here on the left, they share some similar attributes, and the ones on the right also share some similar attributes. By and large, the bad uses of color simply involve using too much color and using it in an arbitrary way, using mappings that don't naturally resonate with the data itself, where you have to be reliant on a legend to look up values. That can be very challenging. When you're using color, if you can map the color onto something that is intuitive, where people might not necessarily need to look up the values, as in this case here, that is much easier. The more you have people looking back and forth from your legend to your visualization, the harder it will be for them because they have to remember that information and do that visual comparison. So all of these are using lots of colors that you have to look up on a scale. Now let's switch over to the good visualizations. Among the things that are going on here is is there seems to be a natural mapping with the colors that they've selected and the data that they're representing. Also notice that they're minimally using color. Some of these cases we're really just talking about 2-3 different colors being used. So they are really being selective in what they use color to encode. That is very important because color has a lot of problems that we'll talk about in future videos. And one way to avoid some of those problems is to be selective when you use color, to really ensure that you're using it in a minimal fashion. And that will adhere to a variety of different design principles as well. I hope this gave you a little insight into good and bad uses of color. When you're out in the world, keep your eye on if you think that a visualization is using color in a good way or in a bad way. And if you see some creative use of color that you think is really interesting. You will be influenced by the information you consume. So if you are looking at more good data visualizations, then you yourself will produce more good data visualizations.